Okay, in this video, we're going to learn about another type of interest. Okay, so as you remember, before this, I already explained we're going to learn two types of interest. So the first one is simple interest, and second one here is compound interest. Okay, recall for simple interest, the interest rate, which is value R. Okay, so interest rate is for 1 year, means that the interest rate is per annum. Okay. And now look at what is compound interest and what is the difference between compound interest and simple interest. Okay, compound interest is based on principle. So also we have concept principle here, but it changes from time to time. Okay, so this is the first difference for compound interest with simple interest. Okay, so simple interest, it based on original principle. But compound interest, the principle changes from time to time. Okay, in compounding, we calculate the interest periodically. Okay, so we calculate the interest periodically over the borrowing money and add it to the principal. This adjusted principal, okay, we have new term here, adjusted principal, which is the original principal plus the interest. Okay, so this one we call it as adjusted principal. Then becomes the principal for the next calculation of interest. Okay, so meaning to say that, for example, okay, let's say year 1, you borrow for, let's say P is 1,000 ringgit. After 1 year, you need to pay interest of, for example, 50 ringgit. Okay, so year 2, now your principal will be your original principal 1,000 plus 50 ringgit. So now new principal in year 2 is 1,050 ringgit. Okay, this is principal for second year. Okay, so in second year, in order to calculate interest, value P here now is 1,050 ringgit. So 1,050 ringgit here, we call it as adjusted principal. Here, principal which changes from time to time, meaning to say that year 1 just now, our principal is 1,000. Year 2, our principal is 1,050. So that is the difference between compound interest and simple interest. If simple interest, okay, example, year 1, your principal is 1,000. Year 2, year 3, and so forth, your principal also still based on original principal, which is 1,000. Okay, but in compound interest, later on your principal will be changes from time to time. So that is the difference. Okay, because the interest is added to the principal, the interest itself earns interest during the next time period for computing interest. Okay, so example here, later on in year 2, in calculation of interest, I equals to PRT, for example, the principal we will use value 1,050 ringgit, not your original principal. So that is meant by the interest itself earns interest during the next time period for computing interest. Okay, this is what is meant when it is said that the interest is being compounded. Okay, the interest itself earn interest in the next time, during the next time period for computing interest. Okay, the interest being compounded. The final sum at the end of the borrowing period is called as compound amount. So compound amount is actually similar to concept simple amount. Okay, value at the end of certain period. Here compound amount, we still use symbol S. Okay, similar to maturity value or simple amount. The concept still the same. Value at the end of certain period or accumulated value. Simple amount, or another concept for S here is maturity value. value at the end of certain period. But here, compound amount under concept compound interest. Okay, thus we can say that compound interest is the difference between the original principal and the compound amount. So how we calculate compound interest? Compound amount minus original principal. Okay, so there is no formula I equals to PRT in compound interest topic. Okay, so how we calculate compound interest? I equal to S minus P. So compound amount is value S and original principal here is value P. So original principal refer to principal in first year. Okay, so remember under topic topic compound amount, don't use formula I equals to PRT. I equals to PRT only for topic simple interest. Okay. Another one, how to differentiate between simple interest and topic compound interest. So again, the keyword will be, if compound interest, it will say compound word. Okay, the word compound will be mentioned. And if simple interest, word simple interest also will be mentioned. So don't wrong formula. Let's look at some important terms under compound interest that you need to know. Okay, the first one, original principal, which is value P. So again, original principal here, similar to previous topic under simple interest. So P is the amount of loan or deposit. Okay, next, frequency of conversion, M. Okay, lowercase m, frequency. So what is frequency of conversion? It is the number of times interest is calculated in a year. In a year means in 1 year. Okay, how many times we calculate interest in a year? So that is frequency of conversion or value M. So after this, I explain detail about value M. Okay, next, conversion period or interest period. So if period means that referring to time. Okay, so what is conversion period or interest period? So it is the length of time in which interest is calculated. Okay, so about length of time. Okay, now let's look at some conversion period and its frequency of conversion. Okay, first we have compounded annually. Okay, compounded annually. So what is the conversion period or interest period? Now, it is about length of time. So if your interest is compounded annually, means that the period or we need to wait for 1 year or also equivalent to 12 months. Then we calculate the interest. Okay, conversion period or interest period, length of time in which interest is calculated. So if bank offered you loan compounded annually, means that the interest will be calculated by annually. Means that you wait 1 year, then interest will be calculated. Or also we can say that we wait 12 months, which is equivalent to 1 year, then the interest will be calculated. Okay, now look at frequency of conversion here. So what is the definition of frequency of conversion just now? So it is the number of times or the frequency the interest is calculated in a year. In a year. So be careful with this definition. In a year. Okay, in 1 year. So just now compounded annually. We wait 1 year, also equivalent to 12 months. So frequency of conversion, how many times of frequency that we calculate interest? So value M here equal to 1. Okay, so you wait 1 year, so M equal to 1. Okay, because the definition just now, number of times interest is calculated in a year, in 1 year. Okay, next, compounded semi-annually. So what is the conversion period? So if semi-annually means that we wait 6 months, and then the interest will be calculated. Okay, so period is 6 months. We wait 6 months, then the interest will be calculated. Okay. Now look at frequency of conversion. M equal to 2. So how we get M equal to 2? Okay. Since the period is 6 months, the frequency just now, how many times or frequency the interest is calculated in a year, in 1 year. So if every 6 months within 1 year, we will calculate the interest for 2 times, okay, or twice. So that's why here M equal to 2. Example, January to June, 6 months, so you calculate interest. So that is the first time interest being calculated. And then you wait from July until December, which is another 6 months. Then you calculate interest again. Okay, so within 1 year just now, January to December, how many times we calculate interest? 2 times. Okay, if compounded semi-annually, the period is every 6 months. Frequency will be equal to 2. Value M equal to 2. Okay, if compounded quarterly, so what is the period or interest period? Every 3 months. Okay, for example, January, February, March. You wait 3 months and then calculate interest. And then April, May, June, another 3 months. Okay, you calculate second interest. So within 1 year, if compounded quarterly, so altogether in 1 year, we will calculate interest for 4 times. Okay, example, later on I will show with diagram for compounded quarterly, how we get M equal to 4. Okay, if compounded monthly, so what is the conversion period? How long we need to wait to calculate interest? So compounded monthly means that every month the interest will be calculated. So means that the period or the time that we need to wait is 1 month. Or we also can say 30 days or 31 days. Okay. So within 1 year, how many times? If every month you calculate interest, so M will be equal to 12. Okay, then compounded every 2 months. For example, January, February, 2 months. Okay, calculate interest. And then March, April, another 2 months, calculate interest, and so forth. So within 1 year, if compounded every 2 months, we will calculate interest 6 times. Okay, in 1 year, we will calculate interest 6 times. Okay, and we have compounded every 4 months. So if every 4 months, for example, January, February, March, April. So that is the first time interest being calculated. And then May, June, July, August, another 4 months. So that is the second time interest is being calculated. So within 1 year, later on, if compounded every 4 months, M equal to 3. We will calculate interest 3 times if the interest is compounded every 4 months. After this, I will explain with diagram for conversion period and its frequency conversion. Okay, for annual nominal rate. So annual nominal rate, we use symbol K. Annual means for 1 year. Okay, if simple interest, the interest rate given, which is value R, is for 1 year. But compound interest here, the rate for 1 year, we call it as nominal rate, which is value K. Okay, so nominal rate is rate for a year. For a year means for 1 year. Okay, now look at periodic interest rate. Okay, previously nominal rate, value K, nominal rate, rate for 1 year. Now I rate for each interest period. Okay, for each interest period. So just now interest period, we have compounded quarterly, compounded semi-annually, compounded every 2 months, compounded every 4 months. Okay, so that is interest period. So for example, compounded quarterly. Compounded quarterly means that M equal to 4. So every quarter, how many percent? Okay. So how to calculate periodic interest rate? I. So I is given by K divided by M. So K just now rate for 1 year. Okay, and M is frequency of conversion. So rate for 1 year divided by how many times we calculate interest in 1 year. Okay, example, look at example 1 here. Okay, given K equal to 12%, so K just now nominal rate, which is rate for 1 year. M, frequency of conversion. Okay, if let's say the interest is being compounded quarterly, so value M equal to 4. In 1 year, we calculate interest 4 times. Okay, so value I, interest rate per interest period, or for each interest period, equal to K divided by M. So K here is 12% divided by M, which is equal to 4. So 12% divided by 4, we get 3%. So what is meant by 3% here? Okay, look at this diagram. Okay, K 12% is the rate for 1 year. Let's say we start from January, so 1 year will be until December. Compounded quarterly, so if compounded quarterly, the interest period is 3 months. Okay, just now here, compounded quarterly, interest period is every 3 months. And then within 1 year, we will calculate interest 4 times. Okay, if you look at this diagram, okay, every 3 months, January, February, March, we wait 3 months, then we calculate the interest. So that's why M equal to 1 here. First time we calculate the interest for the first 3 months. Okay, next 3 months, April, May, June, calculate another interest, okay, which is M equal to 2. Second time we calculate the interest. Okay, next 3 months, the third 3 months, July, August, September. Okay, and then here M equal to 3. And then last quarter, October, November, December, we wait another 3 months, then we calculate interest. So now here M equal to 4. Within 1 year, January until December, we calculate interest 4 times. 1, 2, 3, 4. Okay, why we calculate 4 times? Because if compounded quarterly, we need to wait 3 months, then we calculate the first interest. Okay, means that the conversion period is 3 months, or the interest period is 3 months. Okay, if K is 12%, 1 year, 12%. Okay, if 3 months, for every 3 months, so that's why here K divided by M. Within 1 year, how many times we calculate interest? 1, 2, 3, 4. So 12% rate for 1 year divided by how many times we calculate interest in 1 year. So 12% divided by 4, we get 3%. So meaning to say that every 3 months, the interest is 3%. So that is value I, periodic interest rate, which is rate for each interest period. Each interest period here referring to January, February, March, every 3 months. April, May, June, another 3 months. So 3%, 3%, 3%, 3%. So if you total up later on, within 1 year, the rate will be equivalent to 12%. Okay, example 2 here. Okay, let's say rate for 1 year is 10%. So K equal to 10%. M equal to 2. Okay, this one if the interest is being compounded semi-annually. Okay, if semi-annually, the interest period is every 6 months. We wait 6 months and then calculate interest. And then we wait for another 6 months. For example, here July until December, we calculate another interest. So within 1 year, how many times we calculate interest here? If semi-annually, 1, 2. So M equal to 2. If M equal to 2 and rate for 1 year is 10%, so every 6 months, how many percent? So K divided by M. So 10% divided by 2, we will get 5%. So the first 6 months, January until June here, the rate will be 5%. Another 6 months, July until December, another 5%. So within 1 year, the rate will be equivalent to 10%. Okay, 5% plus 5% equivalent to 10%. So again, K is rate for 1 year, I is rate for each interest period. Okay. Okay, last one. Total number of interest period. Okay, this is value n. Okay, what is value n here? Okay, it is the number of times interest is calculated during the investment period. Okay, during investment period or during the borrowing period. Okay, example. Say we borrow money from bank for 2 years. Okay. And interest is being compounded semi-annually. If compounded semi-annually, the interest period is 6 months. So if 6 months within 1 year, we calculate interest twice. Okay, so M equal to 2. Okay, M is number of times interest is calculated in a year, in 1 year. Okay, 1 year, 2 times. If 2 years, how many times we calculate interest? It will be 2 times 2 equal to 4. Okay. If we borrow money from bank for 3 years and interest is compounded semi-annually. So if semi-annually, again, M equal to 2. So 1 year, twice. So if 3 years, so how many times we calculate the interest? 2 times 3. Okay, which is equal to 6. Or we borrow money from bank for 2 years and compounded monthly. Monthly means every month. So M equal to 12. So 1 year we calculate interest 12 times. So if 2 years, and how many times we calculate the interest? So 12 multiplied by 2, which is equal to 24. Okay. So that's why if you look at here, the formula N equals to M times T. M is the number of interest is being calculated in 1 year, or the frequency of conversion, and T referring to the investment period or borrowing period. Okay, so N equals to M times T. So that is total number of interest period. Okay, then last one here, future value or compound amount, which is value S. So value S is given by S equal to P multiplied by 1 plus I to the power of N. So again, P is the original principal, I is the interest rate for each interest period, and N is the number of interest period. So this formula also, you can write it as S equal to P 1 plus K over M. Okay, so K over M is value I. Power of, so how we calculate N just now? M times T. Okay, so that is future value or compound amount or accumulated value under compound interest topic. So after this, we will look at some examples. Okay, now let's look at this example. Okay, so a situation is given here, then you need to identify the values according to each term. Okay, 1,000 ringgit is invested at 5% compounded semi-annually for 2 years and 6 months. Okay, A, find the original principal. So here original principal is 1,000 ringgit. So you put here P is 1,000 ringgit. Okay, this exercise is just to identify the value according to terms under compound interest topic. Okay, annual interest rate. So remember, annual interest rate is rate for 1 year. So in compound interest, rate for 1 year is value K. So K here is 5%. 0.05. So if you write 5% also, no problem. Okay, then interest period. Okay, interest period, you need to look at the frequency of conversion. Okay, compounded semi-annually. If semi-annually, then the interest period will be 6 months. Okay, how long we wait in order to calculate interest? Okay, so if semi-annually, we wait 6 months, then we calculate interest. Okay, frequency of conversion. Frequency of conversion means that how many times we calculate interest in a year. Okay, for 1 year. So if interest period is now 6 months, so within 1 year, how many times we calculate interest? 2 times. Okay, so this is value M. M equal to 2. For example, January until June. Okay, this is the first time we calculate interest. And then July until December, another 6 months. This one will be the second time we calculate interest. Okay, so that's why here M equal to 2. Period, interest period, we wait 6 months. Okay. Okay, interest rate per interest period. So just now 5% rate for 1 year. Okay. Now interest rate per interest period. So just now interest period 6 months. So if 1 year 5%, 6 months how many percent? So this is actually value I. So how we calculate I? K over M. 5% divided by 2. So here we get 2.5% or 0.025. So meaning to say that January until June is 2.5%. Okay. July until December, another 6 months, another 2.5%. So within 1 year, the rate is 5%. Okay, so that is interest rate per interest period. Okay, last one, number of interest periods in the investment period. Okay, number of interest period in the investment period. So just now, interest period is 6 months. Frequency of conversion is twice or M equal to 2. 1 year, we calculate interest 2 years. Okay, now our investment period here is 2 years, 6 months. Okay, we invest for 2 years and 6 months. So this is value T. So remember T must be in year. So 2 years, 6 months plus 6 months. Months convert to year, divide it by 12. So here T we get 2.5 years. Okay. So in this case T equal to 2.5. Okay, number of interest period in the investment period is value N. Meaning to say that M is how many times we calculate interest within 1 year. And how many times we calculate interest for the investment period. For the investment period, meaning to say that in this case is 2.5 years. So N equals to M times T. So 1 year we calculate interest twice. Okay, 2 times. If we invest for 2.5 years, then we calculate 2 multiplied by 2.5. Okay, so which is 5. Okay, so within 2 years and 6 months, we calculate interest if the interest is compounded semi-annually. So within 2.5 years, we calculate interest for 5 times. Okay, so that is number of interest period in the investment period. Okay, now look at exercise 13 here. So in this exercise, I'm going to show you the difference between simple interest and compound interest. Okay, now let's look at example A. So example A, if we are using simple interest. So remember, what is the difference between simple interest and compound interest? So under simple interest, in the calculation of interest, the principal is always based on original principal. However, in compound interest, the principal will be changes from time 2 times. Okay, so that's the difference. Okay, 2000 ringgit is invested for 3 years. Okay, find the interest earned if the interest rate, okay, for A is 8% per annum using simple interest. So I put in a box or table like this just to show how we calculate it year by year. Okay, so since for 3 years, so that's why here I have 3 rows. Okay, year 1, year 2, year 3. Okay, if simple interest, our principal just now is 2000 ringgit. Okay, interest earned, how we calculate interest? So I equals to PRT, principal 2000, rate 8%, okay, T equal to 1, okay, year 1. This one we calculate year by year. So this one, if we calculate interest, we will get 160 ringgit. Okay, accumulated amount, so this is value S, okay, or simple amount. So just now we invest 2000. After 1 year, we will earn interest of 160 ringgit. So after 1 year, we will get, so S equal to principal 2000 plus interest earned for 1 year. So after 1 year, we will get 2160 ringgit. Okay, now year 2. Okay, how to calculate interest year 2? Okay, based on original principle. Okay, simple interest always based on original principle. So how we calculate interest here? 2000. So still based on original principle. Multiply by rate. And then T here is 1 year. Okay, why T here equal to 1, not equal to 2? Because now I'm showing you how to calculate the interest year by year. Okay, so after this, I show you using formula. So here, second year also, you will earn interest of 160 ringgit. Okay, so at the end of year 2, how much you will earn? Okay, year 1 just now, you already had 2160. Okay, after year 2, you earn another interest of 160. So plus 160. So at the end of year 2, you will earn RM 2160 plus 160 is 2320 ringgit. Okay. Okay, now last year, third year, how to calculate interest? If using simple interest, also based on original principle, which is 2000 ringgit. So I here equal to 2000 multiply 8% multiply 1. Why 1? Because referring to third year. Okay. Now we calculate year by year. So third year you also earn interest of another 160 ringgit. So at the end of year 3, how much you will earn? So previous year you already had 2320. Year 3 you already earn another 160 ringgit of interest. So at the end of that year, you already had 2,480 ringgit. Okay. So this one I show you calculation of year by year. Okay, let's say we use formula or we substitute the value directly. Okay, let's say I calculate interest here. I equals to PRT. So principal 2000, rate 8%. Okay, T 3 years, right? So if you calculate this one, you will get 2000 times 8% times 3 years, you will get 480. Okay. So if you look at here, if you total up this one, you also will get 480, right? So this one in this table, I show you we calculate year by year. Okay, if accumulated amount or simple amount S equal to P1 plus RT. So if you substitute directly using formula, P is 2000, rate 8% and T is 3 years. So if you calculate this one, you will get RM 2480. Okay, so which is value at the end of third year. Okay, so this one we use simple interest. Okay, so again, simple interest, calculation of interest based on original principal. So throughout the 3 years, the principal are the same. Okay, so that is simple interest. Okay, now let's look at using compound interest. Okay, now look at example B. So for the same amount of principal, which is 2000, okay, but we use 8% compounded annually. So if compounded annually, M equal to 1. Okay, so within 1 year, we calculate interest once or one time only. So in this case, why I put I equals to PRT? Since it is compounded annually. Okay, and now look at how to calculate interest for first year. Okay, principal just now still 2000. Okay, if compounded annually, how we calculate interest? 2000 multiplied by rate for 1 year, which is 8%. So in this case, K equal to 8%. Okay, M equal to 1. Interest rate per interest period means that for 1 year, I equal to K over M. So 1 year, interest is 8%. Compounded annually, M equal to 1. So within 1 year, the rate is also 8%. Okay, so that's why I put I equals to PRT here, because it is compounded annually. Okay, this one just example in order to show you how we calculate interest year by year and to compare the difference between simple interest here and the compound interest here. So T equal to 1. Okay, because year 1, and since it is compounded annually. So year 1, we will get 160 of interest. So after 1 year, this one is value S. So S equal to again 2000 plus interest 160. So after 1 year or at the end of 1 year, you will get 2160 ringgit. Okay, now year 2, how to calculate interest in year 2? So remember, in compound interest, the principal is changes from year to year. Okay, now second year, the principal will be 2160 ringgit. Okay, so this one we call it as adjusted principal, where original principal plus the interest. Okay, so that's why in compound interest, we say that the interest itself earn interest from the previous interest. Okay, so second principal or second year principal here is 2160. So we're going to use this value in order to calculate interest for second year. So second year interest is, okay, not 2000, the principal is not 2000 ringgit anymore. Now the principal is 2160. So rate for 1 year 8% and multiply by 1. Okay, so this one because it is compounded annually, M equal to 1. Because later on, if you calculate N equal to M times T. So M equal to 1, T equal to 1. So 1 multiplied by 1, you will get 1. So that's why I show using compounded annually in order to compare with formula I equals to PRT. Okay. If later on, if compounded semi-annually, compounded quarterly, you cannot use formula I equals to PRT, okay, because formula I equals to PRT only for simple interest. Okay, so this one I just want to show you the different amount of principal in calculation of simple interest and compound interest. So here, how much interest you will get on second year? 2160 multiplied by 0.08 times 1. 172 ringgit 80 cents. Okay, after year 2 or at the end of year 2, how much you earn? So previously you had 2160 plus the interest. So second year interest is 172 ringgit 80 cents. Okay. So at the end of year 2, how much you earn here? So 2160 plus the interest just now. Okay, so here interest plus 2160. So at the end of year 2, you will get 2332.8. 2332.8. So this value, okay, accumulated value at the end of year 2 will be the new principal for third year in order to calculate interest. Okay, so third year principal now will be 2332.8. So how we calculate interest? Okay, now new principal 2332.8 times the rate of interest and times the. So this one multiplied by 8%. So third year interest that you will earn is 186 ringgit 62 cents. 62 cents, right? Okay. So at the end of year 3, how much you will earn? The previous year or year 2, you already had 2332.8. Okay, plus interest that you earn in third year, which is 186.62. So at the end of year 3, you will get RM 2332.8 plus 186.62. 2519.42. Okay, so if you look at here, if using compound interest, okay, so the principal is changes from year to year, okay, but if we are using simple interest, it always based on original principal. Okay, so if you invest for 10 years, so principal for 10 years always based on 2000 ringgit. Okay, that one case of simple interest. But if using compound interest, the principal will be changes from year to year. Okay, and if you look at values at the end of third year, okay, if using simple interest here is 2480. If using compound interest is 2519.42. Okay, so if you look at here, if using compound interest, you will get more, okay, to 519.42 as compared to amount that you will earn using simple interest. Okay, because why? Because in calculation of interest, okay, the principal is changes from year to year because the interest itself earn interest from previous year. Okay, so here, for example, here 2160. So in order to calculate interest here, it is based on interest from previous year. Okay, so that is mean by the interest is being compounding. Okay, the interest itself earn interest from previous year interest. So I hope you can see a difference between simple interest and compound interest. Okay, look at this exercise 14. Okay, this one also I show you manually one by one or year by year. Okay, Sheena deposited 200 ringgit in a saving account at annual compounded rate of 9% for 4 years. So here P is 200 ringgit. Annual compounded rate, so 9% is value K. Okay, compounded. So if you see word compounded means that under topic compound interest. Okay, so use a formula under topic compound interest. So if annual means that the frequency of conversion M equal to 1. Okay, for 4 years. So T equal to 4 years. How much compound amount? Compound amount is value S. Okay, value at the end of 4 years. And compound interest is value I. Okay, that Sheena earned. Okay, now let's calculate. Okay, I equals to, okay, first year, the principal is 200. Okay, rate is 9% multiplied by 1. Okay, so this one similar to previous example. Since it is compounded annually, so we can calculate like this. We substitute t equal to 1. Okay, so here the interest will be 18 ringgit. Accumulated amount, which is value S. So just now you invest 200 ringgit. After 1 year or within 1 year, you earn interest of 18 ringgit. So at the end of year 1, we will earn 218 ringgit. Okay, this value 218 ringgit will be the new principal in the calculation of interest for second year. Okay, so second year, I equal to 218. Okay, now principal is changed. Okay, multiply the rate. So 218 multiplied by 9% is 19 ringgit 62 cents. So year 2, how much you earn? So previously you had 218. Okay, plus interest second year, which is 19 ringgit 62 cents. So after 1 year, the accumulated amount is plus 218, 237.62. Okay, now this value will be a new principal in the calculation of interest in third year. So here I equal to 237.62 times 9% times 1. So interest here is 21.39. Okay, 21.39. So at the end of year 3, we will have, so previously we had 237.62 plus interest in third year 21 ringgit 39 cents. So at the end of third year, accumulated amount is 237.62 plus 21 ringgit 39 cents. 259.01. Okay. Then this amount will be new principal on fourth year. Okay, in order to calculate the interest. 259.01 times 9% times 1. The interest on fourth year is times 9%. 23.31. So accumulated amount at the end of fourth year is, so previous year we had 259.01 plus interest on fourth year is 23 ringgit 31 cents. So at the end of fourth year, we earn 23 ringgit 31 cents plus 259.01. 282.32. So value at the end of fourth year, here we call it as compound amount. Okay, value S. So S here equal to 282.32. So what is the compound interest? So compound interest is the difference between compound amount and original principal. So compound interest equal to I equal to S minus P. So 82.32 minus original principal 200 ringgit. So compound interest is 82 ringgit 32 cents. Okay, so notice that here in calculation of compound interest, the principal is changes from year to year. Okay, now let's look at exercise 15. Okay, find the interest and future value. Future value means that value S, okay, or the compound amount. Interest value I. For 2000 ringgit invested for, so here I give you several example interest period. Okay, now let's look at start from B. A you can refer later on. Okay, we extract the info given first. Okay, so you extract the info on the right hand side here. So just now P is 2000 ringgit. Okay, B 5 years 6 months, so that is value T. T must be in year, 5 years 6 months. So months convert to year, divide by 12. So T equal to 5.5 years. At 4% compounded semi-annually. 4% is K. K annual rate. Semi-annually means that the interest period. So semi-annually, M equal to 2. Okay, now we want to find the future value or the compound amount. So S equal to P1 plus I to the power of N. So if you look at this formula, you need to calculate value I and value N first. Okay, so I advise you to calculate it separately. So calculate value I first. I equal to K over M. So 0.04 divided by 2 equal to 0.02. And value N, M times T. So M equal to 2, T equal to 5.5. 2 times 5.5 equal to 11. Okay, now you substitute the value into formula. So S equal to 2000 multiply 1 plus I. So I just now 0.02 and equal to 11. So K is rate for 1 year. Okay, so since the interest period is semi-annually, so interest period will be 6 months. So rate for every 6 months is 2%. Okay, so another 6 months will be another 2%. So total 1 year rate will be equivalent to 4%. Okay, semi-annually M equal to 2, meaning to say that within 1 year we calculate interest twice. Okay, 2 times. So if the investment period is 5.5 years or 5 years 6 months, so altogether how many times we calculate the interest? So that's why here 2 multiplied by 5.5. So within 5 years and 6 months, in total of 11 times we calculate the interest. Okay. So here S equal to RM. Okay, how to calculate this one? Okay, 1 plus 0.02 is 1.02 power of 11 equal multiply by 2000. So this one you can calculate directly. So the answer is 2486.75. 2486.75. Okay, now amount of interest. So how to calculate interest? I equal to S minus P. So S to 486.75. Original principal 2000, so minus 2000. So amount of interest here is 486 ringgit 75 cents. Okay. Okay, now look at example C. Okay, extract the info first. So here P still 2000 for 2 years 3 months. So T 2 years plus 3 months. Months convert to year divided by 12. So if you calculate this one, you will get 2.25. At 8% compounded quarterly. So 8% is annual rate, which is value K. Compounded quarterly. So frequency of conversion M equal to 4. But the interest period is 3 months. Okay, so we wait 3 months, then we calculate interest. So if 3 months within 1 year, how many times we calculate the interest? 4 times. Okay, as usual, you calculate value I first, interest rate per interest period, means that for every 3 months, how many percent? So I equal to K over M. 0.08 divided by 4 is 0.02, and N equal to M times T, 4 times 2.25. Okay, 4 times 2.25 is 9. Okay, calculate value S equal to P1 plus I power of N, so P2000, 1 plus 0.02, N equal to 9. So S equal to Rm. 1 plus 0.02 is 1.02 power of 9 equal times 2000. So 2390.19. So interest I equal to S minus P. So interest RM 390 ringgit 19 cents. Okay, example D. Okay, extract the info again. T still 2000. T 4 years 6 months. Months convert to year divided by 12. So this one 4.5 years. Okay, at 12% compounded monthly. So annual rate K 0.12. Conversion period compounded monthly every month. So within 1 year, how many times we calculate interest? So here M equal to 12. Okay, again, calculate interest rate for each interest period. So means that every month, how many percent? So I equal to K over M. So I is 0.01. So every month is 1%. And so 1 year, we calculate interest 12 times. So if 4.5 years, how many times? So 12 multiplied by 4.5. So how many times? 54 times. Okay, calculate S. S equal to P1 plus I power of N. One point zero one power of 54 multiply 2000. 3422.82. 3422.82. Okay, value at the end of 4 years, 6 months. Okay, interest I equal to S minus P. 3422.82 minus 2000. RM 1422.82. Okay, last example. P still 2000. and 8 months. So 8 months, 8 divided by 12. Okay, 8 over 12 is, okay, if you look at here, you get long decimal points, right? Okay, if you want to use up to 4 decimal point, you will write it as 2.6667. Okay, if you want to write in fraction also no problem, plus 2. Okay, so if you write in 4 decimal point, if you want to write in decimal point, you will write 2.6667. If you want to write in fraction also no problem. Okay, so example in fraction, 2 over 3 or 8 over 3. Okay, so if you want to use fraction, you write it as 8 over 3. Okay, so 8 over 3 later on in calculation of value s, it will consider that long decimal point. Okay, so if those who are using decimal point up to 4 decimal point and using fraction, your answer will be slightly different. Okay, so no problem as long as your method is correct. Okay, key annual rate 6%, conversion period M compounded every 2 months. So 1 year we have 12 months. So if the interest was compounded every 2 months, how many times? 12 divided by 2. So we get 6. Okay, so M equal to 6. So within 1 year we calculate interest 6 times. Okay, 1 year we calculate interest 6 times. So for 8 over 3 years or 2 years and 8 months, how many times? So n equals to m times t. T just now, let's say I use fraction. So 8 over 3 multiplied by 6. So equal to 16. Okay, if you use decimal point here, okay, look at how you calculate value n. So n equals to m times t. So this one you will get 16.0002. Okay, so for value n is how many times we calculate interest. Okay, so it cannot be in decimal point. So if you get in decimal point, make sure you round off to nearest whole number. Okay, because how many times we calculate the interest. So we cannot say that, oh, we calculate the interest 6.3 times. Okay, we cannot say that. So you get this answer because just now you already round off your answer or t value using decimal point. So that's why your answer will be slightly different. So here you write it equal to 16. Let's say you get 16.0002 and round off to nearest whole number. Okay. So I equal to K over M, interest rate for each interest period. So means that every 2 months, how many percent? So here is 0.01. Okay, calculate value S. S equal to P1 plus I power of N. So P 2000. 1 plus I just now 1%, 0.01. So N equal to 16. 1.01 power of 16 multiply 2000. 2345.16. Okay, calculate the interest. So I equal to S minus P. P 2000. So interest RM 345 ringgit 16 cents. Okay, so that's how you calculate compound amount, which is value S, and interest I equal to S minus P. So make sure don't confuse with simple interest. With compound interest, you must have word compounded here. Okay, now let's look at example 6. Mimi invests 20,000 in an account for 5 years. So 5 years here is the investment period. Okay, the investment account pays 12% compounded semi-annually for the first 2 years. So first 2 years compounded semi-annually. Okay, rate 12%. And 15% compounded every 4 months for the rest of the period. For the rest of the period, meaning to say that another 3 years. Okay, so total investment period is 5 years. So first 2 years, the rate is 12% and compounded semi-annually. So for the rest of the period means that balance another 3 years. Okay, for question like this, I advise you to extract the information given into timeline like this. Okay, so you draw a line like this and then you extract the info given. Okay, for example here, Mimi invests 20,000. So this is the principal. So principal must be at the beginning. Okay, so here principal 20,000 for 5 years. So for 5 years means that the investment period. So total investment period here 5 years. Okay, the investment account pays 12% compounded semi-annually. So that is for the first 2 years. Okay, that is the first stream. Okay, first 2 years. Okay, from start here until here, let's say I put t equal to 2 here. Okay, so within this time period, t equal to 2. So within this time period, within these 2 years, the rate is 12% compounded semi-annually. So semi-annually, m equal to 2. So the rate is 0.12 value k. So if semi-annually means that the interest period is every 6 months. Okay, so here you need to find the interest rate for each interest period. So K just now interest rate for 1 year. Now interest period is 6 months. So every 6 months, how many percent? Okay, so that one referring to value I. So I equal to K over M. So 0.12 divided by 2, we get 0.06. So every 6 months, the interest is 6%. Okay. Okay, M equal to 2. M equal to 2 means that within 1 year or for 1 year, we calculate interest 2 times. So if 2 years, how many times we calculate the interest? So that one referring to value N. Okay. So 1 year, we calculate interest 2 times. So if 2 years, multiply by 2. So within 2 years, we calculate interest 4 times. Okay, now look at next stream. 15% compounded every 4 months for the rest of the period. For the rest of the period means that another 3 years. Okay, so 15% is rate for 1 year, value K, compounded every 4 months. So 1 year we have 12 months divided by 4. So meaning to say that 1 year we calculate interest 3 times. So that's how we get M equal to 3 here. Okay, the interest period is 4 months. This is interest period every 4 months. Okay, K 15% rate for 1 year. So if every 4 months, how many percent? So that one referring to value I. So I equal to 15% rate for 1 year divided by frequency of conversion. 1 year we calculate interest 3 times. So divided by 3. So every 4 months the interest rate is 5%. Okay. 15% divided by 3, we get 5%. Okay, within 1 year, we calculate interest 3 times. So if 3 years, how many times? So the one referring to value n. 1 year 3 times, so if 3 years, multiply by 3. So within 3 years, we calculate interest 9 times. Okay, so you extract the information given like this. Okay, this is example of one principle. Okay, so here we have one principle only. So next example, we will look at, for example, we have second principle here. Let's say at the end of 2 years, maybe you put another 1,000 ringgit. Okay, so this is different case, but now we look at for one principle first. Okay, look at question A. What is the future value of her investment? Means that the investment period is 5 years, right? So we want to know at the end of 5 years here, what is value S? Okay, the accumulated amount or the future value or the compound amount. Okay, now if you look at here, within 5 years, we have two different rates. Okay, 12% and after 2 years, change to 15%. So in this case, you need to calculate future value at the end of 2 years first. Okay, so here I put it as S1. Okay, why you need to calculate value S1 here? Because after 2 years, now the rate is different. Okay, so that's why you need to calculate future value at the end of 2 years first. Okay, if you look at here, S1, so use formula P S equal to P1 plus I power of n. So P is 2000, 1 plus I, so I is 0.06. Okay, so now we want to calculate future value after 2 years. Okay, so you keep 20,000 in bank for 2 years. So at the end of 2 years, how much you get, which is value S1. Okay, power of n. So n within 2 years, how many times you calculate the interest? 4 times. And then power of 4. So at the end of 2 years, you will get to 5. So here you get Rn to 5 249.54. Okay, but now we want to calculate or we want to know value at the end of year 5 here. So this amount value at the end of 2 years. So you have another 3 years. So how to calculate amount at the end of 5 years? So if you look at here, I put it as S2. Okay, so S2 is actually value S1. Okay, if you keep it for another 3 years. Okay, 25,249 ringgit 54 cents. If you keep for another 3 years here, so what is the accumulated amount? Okay, value at the end of year 5. So still we use compound amount formula S equal to P1 plus I power of n. Okay, remember in compound interest, the principal is changed every year. Okay, so now in the next calculation of value S here, S1 will be your new principal. Okay, not 20,000 anymore. Now S1 will be the new principal. Okay, so here if S1 we keep it for another 3 years, it becomes, okay, so use formula compound interest. So P 25249.54. So this amount, okay, value at the end of 2 years just now, we want to bring it or we keep it for another 3 years. Okay, so another 3 years, what is the rate? 0.05. I is 0.05. So within these 3 years, every year we calculate interest 3 times. So if 3 years, we calculate interest 9 times. Okay, so power of 9 here. So when you calculate this one, at the end of 5 years, S here or value S2, we will get RM 39,170 ringgit 32 cents. Okay, so this is example of one principle. After this, we will look at different example. For example, if we have two principles, one rate, or two principles, two rates. Okay, question B, find the interest earned from this investment. So interest are equal to S minus P. So S referring to value at the end of 5 years just now, 39,170.32. So principal, we only have one principal, so minus 20,000. So interest will be 19,170 ringgit, 32 cents. If let's say you have two principal, let's say at the end of year 2, you put another 1,000 ringgit. So here you minus another 1,000 ringgit. Okay, so after this, we will look at how about if we have two principals. Okay, now let's look at example exercise 16. Okay, Hanan saved 3,000 ringgit now and another 1,000 after 3 years. Okay, so this example, we have two principals in an account paying 12% compounded quarterly. So in this case, we have one rate only. Previous question, we have one principal but two rates. Okay, now this example, two principals but only one rate. Okay, find the amount and the total interest in the account at the end of 5 years from now. From now means that start from the first investment. So total investment period is 5 years. Okay, as I said before, extract the info given to this timeline. Okay. So here now, so let's say I put P1 equal to 3,000. Okay, for how many years? 3 years. Okay, because after 3 years, you put another 1,000. So let's say here T equal to 3. So after 3 years, you put another principal of 1,000. And total investment period is 5 years. So within this time period, T equal to 3 and here T equal to 2. Okay, 5 years minus 3 years. So here will be another 2 years. Okay, now we have one rate only. So within 5 years, the rate is 12%. So here K 0.12. Here also 0.12. Compounded quarterly. Compounded quarterly M equal to 4. Means that 1 year we calculate interest 4 times. So N here will be 4 times 3. Here another 2 years, how many times we calculate interest? 1 year 4 times. So if 2 years, 4 times 2. So if since we have one rate, okay, one rate, so within 5 years is 12%. So how many times we calculate the interest? M times T. M equal to 4 times T equal to 5. 20 times. Okay, or you can calculate here 12 plus 8. Okay, also equal to 20. Because now we have one rate only. Okay, find the amount at the end of 5 years. Now we have two principles, P1 and P2. Okay, how to calculate amount at the end of 5 years here? Value S. Okay, now look at P1. Since we have one rate only, you can calculate directly. If you keep 3,000 for 5 years, so what is the accumulated amount at the end of 5 years? Okay, so no need to calculate S1 here at the end of 3 years. Okay, you can directly calculate 3,000 for 5 years. Because why? Because we only have one rate. Previously, we calculate S1 here because we have different rates. So here we only have one rate, so you can directly calculate 3,000 until 5 years. Okay, so let's say I put 3,000 here If you keep it until 5 years, the value at the end of 5 years, let's say I put it as S1. Okay, so what is S1? Future value or future amount of P1. Okay, at the end of 5 years. So S equal to P1 plus I power of n. So P is 3000. 1 plus I. Okay, how about I? Since we have one rate only, so I equal to, so calculate I K over M, 0.12 divided by 4. So here you will get 0.03. Okay, how about N? Okay, so now we want to calculate 3000 here for 5 years. So if 5 years, N equal to 20. Okay, not 12 and not 8, because now we calculate for 5 years. So N equal to 20. So here is 1. So if we calculate this one, we will get 1.03 power of 20 times 3000. 5418.33. Okay, now we get S1 5418.33. Okay, that is from the first principle. We have second principle. Okay, second principle P2 here. Okay, we put it at the end of 3 years. So 1000, if we keep for another 2 years, what is the accumulated amount? Okay, let's say we put it as S2. Okay, calculate value S2. So S2 is future value of P2, our second principle, at the end of 5 years, or at the end of year 5. So S2 equal to P1 plus I power of n. P 1000, second principle just now, 1000. I still the same, we only have one rate. Okay, be careful with value n. So second principle just now at the end of 3 years, right? So we keep it another 2 years. So if 2 years, how many times we calculate the interest? 8 times only. So here n equal to 8. So 1266.77. Okay, question asks us what is the amount at the end of year 5? So just now S2 1266.77. So if you look at here, at the end of year 5, how much we have? So at the end of year 5, actually we have S1 and S2. Okay, so your answer will be, so amount or total amount, so total amount at the end of year 5 is, so S equal to S1 plus S2, because just now we have two principles. So 5418.33 plus 1266.77. 6685.1. So find the total interest. So total interest I equal to S minus P. So I equal to S minus P. So S just now 6685.0. Okay, P, be careful. We have two principles just now, right? So minus 3000 and then another one minus another 1000. So interest equal to RM to 685.10. Okay, now look at number 2. A certain sum of money was invested at 8% compounded annually. So we do not know what is value P. Okay, a certain sum of money was invested. So let's say amount that we invest is value P. So let's say P equal to P. Okay, the value is unknown. At 8% compounded annually. K equal to 0.08. So if compounded annually, M equal to 1. How long will it take to double in value? Double in value means that if you invest 1000, later on you will get 2000. Okay, so let's say, example, if P you put 1000, so later on value S double means 2 times 1000. Okay, you will get 2000. How long will it take to double in value? How long referring to value T. Okay, so T equivalent to how many years? So how to find this value? Okay, first we calculate value I. So I equal to K over M. So 0.08 divided by 1, we still get 0.08. Okay, how about N? N equals to M times T. So 1 times T. So we do not know what is T, right? So N equal to T. Okay, 1 times T equal to T. So N also equivalent to T. Okay, we know that S equal to P1 plus I power of N. So S we can write it as 2P. Okay, because to double in value. So if we invest 1000, we will get 2000. So if we invest P ringgit, we will get 2P. So substitute here, S equal to 2P, P equal to P, I equal to 0.08, so N equal to T. Okay, N equal to T. Okay, move P on left hand side to by P. So on right hand side we have 1.08 power of T. Okay, P divided P equal to 1. So here we get 2 equal to 1.08 T. Okay, T now is in terms of power. So in order to find value power of unknown value, we can apply log. Okay, so how to apply log? So T unknown value you bring in front. So T multiply by, okay, then apply log. Dot means multiply. Log 1.08. So if right hand side you put log, left hand side also you must put log. So T equal to log 2 divided by log 1.08. So if power of unknown value, you apply log, okay? So this one, just press a calculator. Okay, log 2. So this one got open bracket, then make sure you close the bracket. Okay, depends on your calculator. divided by log 1.08. So we get 9.006. So you just round off to nearest whole number. So T is 9 years. Okay, in this case, okay, so for example, with a rate of 8% and compounded annually, if you put 1,000 in order to get 2,000, you need to wait for 9 years. Okay, so in general, if you put P ringgit, in order to get 2P ringgit, how long you need to wait? 9 years. Okay. Okay, now look at example 3. If 1,000 ringgit accumulates to 5,054 ringgit 47 cents in 17 years, what is the interest rate compounded annually? What is the interest rate? So interest rate here we want to find value K, annual rate. Okay, so extract the info given. So P is 1,000 ringgit. S is 5054.47. So remember, value S must be more than value P, or P must be less than value S. So 17 years is value T compounded annually. Annually means that M equal to 1. Okay, as usual, calculate value I for compound interest. Calculate value I equal to K over M. So we do not know what is value K, so just put it as K divided by 1. Okay, so K over 1 is K. So I also equivalent to K. And then calculate value N. N equals to M times T. So N equal to 17. Okay, then use formula S equal to P 1 plus I power of N. So we know that S 5054.47 equal to P 1,000 ringgit 1 plus I, so I just now equal to K, N equal to 17. Okay, bring 1,000 to left hand side. 5054.47 divided by 1,000. So on right hand side we have 1 plus K power of 17. Okay, 5054.47 divided by 1,000, we will get 5.05447. And now we want to find K, right? But now power of 17 belongs to 1 plus K. Okay, so bring power of 17 to left hand side first. So power of 17, if you bring to left hand side, becomes square root of 17. Okay, so on right hand side you have 1 plus K. So bring positive 1 to left hand side, square root of 17, 5.05447. So positive to left hand side minus 1. So right hand side you have K. So press calculator, K equal to K minus 1. Make sure you press the calculator correctly. Minus 1 is separately from this, okay? So 0.099999. Okay, so you just round off to. So if you take 4 decimal point, it will be 0.1. So So normally rate we express in percentage, right? So multiply by 100. So K is 10%. So once we know K equal to 10%, so later on you can find value I. Okay, so since I equal to K, so I also equivalent to 10%. Okay, now let's look at question 4. RM 15,000 is invested for 8 years 2 months. So the investment period is 8 years 2 months. This investment offered 12% compounded monthly for the first 4 years. Okay, so first 4 years compounded monthly with rate of 12%. First 4 years. And then 12% compounded quarterly for the rest of the period. Calculate the future value of this investment. So again, we extract the information to this timeline. So in this case, again, we have one principal and two different rates. Okay. So first, we put here P 15,000 and investment period is 8 years 2 months. So T here 8 years 2 months. So 8 years 2 months is 49/6. Okay, or if you want to use decimal point, you round off to up to 4 decimal points. Okay, first 4 years it is compounded 12% compounded monthly. So first 4 years, let's say here year 4, so K 12% compounded monthly, so compounded monthly M equal to 12. Okay, so you calculate I here, I K over M. So I is 0.01. N equal to M times T. So 12 times 4, first 4 years. So here N equal to 48. Okay, for the rest of the period means that for another 4 years and 2 months. So here T is 4 years, 2 months. Okay. So 4 years, 2 months is 25/6. Okay, this one rate is 12%. Compounded quarterly. Okay, now different conversion period. So compounded quarterly M equal to 4. Okay. So here rate is still the same, but conversion period is different. This one, first 4 years compounded every month or monthly. So next 4 years and 2 months compounded quarterly. So here calculate I K over M. So 0.12 divided by 4 is 0.03. N equals to M times T. T 25/6 times 4. Okay, if you look at here, N 16.6667. Okay, so if you use fraction 50/3. Okay, N is the number of times interest is being calculated. Okay, so here, for example, you get 16.6667, round off to nearest whole number, okay, which is 17. Because N is number of times we calculate the interest. Okay, so logically, it must be an integer. Okay, now we want to find future value or accumulated amount at the end of 8 years 2 months. Okay, since we have the same rate 12%, but two different frequency of conversion. Here is compounded quarterly, but here is compounded here is compounded monthly, and second stream here compounded quarterly. So we need to calculate future value at the end of year 4 first. Okay, so let's say I put S1. So what is S1? Future value of original principal. Okay, why we calculate here? Because we have different conversion period. Okay, or if you have different rate also, you need to calculate S1 here first. So how to calculate S1? S1 equal to P1 plus I to the power of n. So principal 15,000, 1 plus I, so I here. So now we are calculating at this time period, okay, first 4 years. So I is 0.01 and n is 48. So S1 is RM 1.01 power of 48 multiply 15,000. So we get 24183.39. 24183.39. So at the end of year 4 here, we have 24183.39. Okay, now we want to know value at the end of 8 years and 2 months. So we have another 4 years and 2 months here. So what if this amount value as 1, we keep for another 4 years and 2 months. So what is the accumulated amount here? Okay, so this amount, so if we wait another 4 years and 2 months, let's say we put it as S2. So what is the amount? S2 equal to P1 plus I to the power of n. So what is value P here? So remember, in compound interest, principal is changes from year to year. So in calculation of S2, S1 now will be the new principal. Okay. So S2 equal to P now is 24183.39 multiply 1 plus. Okay, now we are calculating at this time period. Okay, another 4 years and 2 months. So I is 3%. Okay, n is another 17. So if we calculate this one, 1.03 power of 17 multiply 24183.39. So we get 39971.46. Okay, so at the end of 8 years and 2 months here, we have 39,971 ringgit 46 cents. Okay, so if question asks you to find amount of interest, so interest will be equal to S minus P. So S must be value at the end of the investment period. 39971.46 minus original principal 15,000. So in this case, we only have one principal. So minus 15,000. 24 RM 24,971 ringgit 45 cents. So this is the amount of interest. Okay, so you draw timeline like this so that easy for you to look at the values. Okay, question number 5. What is the annual nominal rate value K compounded monthly? So compounded monthly M equal to 12 that will make 1000 become 2000 in 5 years. So t equal to 5. So 1000 is value p and s is 2000. Okay, so remember value s must be more than p or p less than s. So again, this one is compound interest. So use formula compound interest. S equal to P1 plus I power of n. Okay, as usual, you calculate I first. I equal to K over M. So now we do not know what is value K. So just put it as K divided by M. M equal to 12. N equals to M times T. So 12 times 5 equal to 60. Okay, substitute the value. So S is 2000 equal to P 1000 multiplied by 1 plus I. So I just now is K over 12 power of 60. Okay, bring 1000 to left hand side. 2000 divided by 1000. So on right hand side we have 1 plus K over 12 power of 60. So 2000 over 1000 is 2. Okay, now power of 60 belongs to the whole thing in bracket here. So you bring power of 60 to left hand side. So power, so you bring to left hand side become square root of 60. So here you have on right hand side 1 plus K over 12. Okay, I continue here. Okay, now bring this positive one to left hand side. Minus 1, so on right hand side we have K over 12. So now K over 12, we want K only. So bring over 12 here to left hand side. Okay, so divide to left hand side become multiply. So 60 square root of 60, 2 minus 1 multiplied by 12 equal to K. So press calculator, this one you will get 60, 2 minus 1 and then multiply by 12. So 0.1394. So normally rate we express in percentage multiplied by 100. So annual nominal rate here is 13.94%. Okay. Okay, now let's look at number 6. A certain sum of money was invested at 7% compounded quarterly. So amount that we invest is actually value P. Okay, this investment will be worth 15,000 at the end of the 6 years. At the end of 6 years. So means that this is value S. So S compound amount of future value here is 15,000, which is at the end of 6 years. Okay, find the original principal. So what is the original principal here? So K is 7% compounded quarterly. Quarterly M equal to 4. Okay, now let's calculate value I. I equal to K over M. So 0.07 divided by 4 is 0.0175. Okay, N equals to M times T. T equal to 6. Okay, we know that compound amount S equal to P1 plus I to the power of N. Okay, now substitute the value or you make P as the subject. Okay, so if you make P as the subject, P equal to S divided by 1 plus I power of N. So P equal to S 15,000 divided by 1 plus 0.0175 power of 24. So P is Rm. So value P must be less than value S. So 1.01, so 1 plus 0.0175 is 1.0175 power of 24, and then 15,000 divided by answer referring to value denominator just now, okay, referring to previous answer in this calculator. So P is 9,891 ringgit 57 cents. So value P must be less than value S, 9891.57. Okay, question 7. A house is estimated to cost 120,000 in 10 years' time. Okay, if Jane wishes to buy this house in 10 years' time, how much must she deposit now in account that pays 10% compounded quarterly? Okay, now we need to identify what is 120,000. Okay, it says that 120,000 in 10 years time. Okay, so within 10 years, the cost is 120,000. So meaning to say that this is future value. So if Jane want to buy this house for another 10 years, how much should she deposit now? Okay, so we want to find value P, principal. So now we know that S equal to 120,000, T equal to 10. So what else? K, annual rate is 10%, 0.1, and compounded quarterly. Compounded quarterly, M equal to 4. Okay, calculate value I equal to K over M. 0.1 divided by 4. So 0.025. N equals to M times T. So 4 times 10, 40. So 1 year we calculate interest 4 times. If 10 years, 40 times. Okay, now we want to find P. So make P as the subject from compound amount formula. S equal to P1 plus I power of N. So P equal to S divided by 1 plus I power of N. So S is 120,000 divided by 1 plus I 0.025 and 40. So value P must be less than value S. 1.025, I calculate denominator first. 1.025 power of 40 equals, so 120,000 120,000 divided by answer. So 44,691 ringgit 67 cents. 44691.67. So if Jane want to buy this house in another 10 years, now she need to deposit, or she need to save 44,691 ringgit 67 cents. Okay, because in 10 years time the house is estimated to be 120,000. Okay, last question. Danny invests an amount of money to pay 10% down payment on an apartment that costs 103,700. How much should he invest for 5 years at 7.5% compounded semi-annually to get the down payment. Okay, first you extract the information. Okay, you extract this part first. T equal to 5. K is 0.075. Conversion period M. Frequency of conversion. Compounded semi-annually. Semi-annually M equal to 2. Okay, now calculate the down payment. Okay, cost of the house is 103,700. So down payment that Danny need to pay is 10%. So 10% from the cost is 10%, 0.1 multiply 103,700 is 10,370. Okay, now question asks you, how much should he invest for 5 years at 7.5% compounded semi-annually to get the down payment? Okay, if let's say now you already paid 10,370, so now how much you should save so that within 5 years you will get this amount back. Okay, so what is the amount of down payment here? So this one, we consider it as value S or compound amount. Okay, because within 5 years or another 5 years, you want to get this value back. Okay, so in another 5 years, that means that in future, you need to get 10,370. Okay, so this is value S. So how much should he invest now? So meaning to say that we want to find value P. So again, use formula compound amount S equal to P 1 plus I power of n. Okay, make P as the subject. Okay, calculate value I here. I equal to K over M. So 0.0075 divided by 2 is 0.0375. N equals to M times T. So 2 times 5 equal to 10. So P here equal to 10,370 divided by 1 plus 0.0375 power of 10. So 1.0375 power of 10, 10,370 divided by answer. So 7176.25. So in another 5 years, in order to get this amount back, amount of deposit here, so now Danny should save or should invest 7,170 ringgit and 25 cents in order to get the down payment back. Okay. So for topic compound interest, as you read the question, extract the info given and then directly calculate value I and value N. Okay, so I advise you to calculate these two values separately as compared to you substitute all values directly into formulas. Okay, so that easy for you to press the calculator.